So it makes sense to extend that sort of idea into code here. And so if we were going to create the most basic class possible that represented a car, we might create a class with just a single property. And so that's what this would look like. It says class CL car, and a lot of times I will use the abbreviation CL when I'm naming a class so that I remember in my head that it's a class as opposed to referring to an object. So CL car, and inside that you can see class CL car colon, and it's indented. We have int wheels equals 4. So that car class defines an object or a blueprint for an object that has one variable that's an integer that's equal to 4. Every time I make a copy of that car, or when I instantiate an object using that class, it's going to start out with 4 wheels, period. And I would do that using this syntax here. So I'd say my car equals CL car, and when you instantiate an object, you're always going to use parentheses in the same way that you would use parentheses after a function. Sometimes, and in a minute I'll show you how, sometimes you provide arguments here that then dictate what happens when that class is created, but we're not there yet. So I created an object called my car that is an instance of that class. So I made a car based on that blueprint. It has 4 wheels. So if I want to print the number of wheels that car has, I can print my car.int wheels. I'm not going to print clcar.int wheels because clcar is a blueprint. It does not exist as an object. I have to create an object from the blueprint, and then I access the properties of that object. Okay? And if I want to change the property, if I want to change the value of this variable inside my car, I'm going to say my car.int wheels equals 6. Now my car has 6 wheels.